Right, hello everyone. So I'm just going to make this a little bit better for everyone. So 2013 paper, pretty standard one. So we'll start with this one and hopefully it'll work out. Okay, so find the set of all real values for which 2x squared plus x minus 15 greater than or equal to 0. Okay, so factorize this, I suppose, first of all. Simple enough. Multiple ways of factorizing, so just go with whatever's comfortable for you. 2x, let's say, and x, that'll give you back your 2x squared when you multiply that by the bracket out. We need a 15, so we need factors of 15. Let me see. Let's have a look. Minus 15. Let's see, 5 and a 3. That'll give me a 6 and a 5. So I'll put the 3 there and put the 5 there. And we still need a positive, so we need to generate a negative. So that's probably going to be the positive, and that's going to be the negative. So, and again, eyeball this. So let's solve this. Let's take this one on its own. That's 2x minus 5 equal to 0. Add 5 to both sides. Divide both sides by 2. And then let's do our other side. So we have x plus 3 equal to 0. Take away 3 from both sides. So there's our two possible answers. Now, we still have to put in our inequalities. So we're still going to need to work on that bit of it. So as before, let's do what comes naturally. Let's just quickly sketch this thing. So out here, all we really need to know is what shape. Is it U-shaped, or is it happy, or is it sad, basically? So it's a positive x squared, so it's going to be some type of U-shaped thing. It doesn't make a difference where you draw it, just so long as you're getting that in there. Okay, so let's put in these roots. So there's your negative 3, and there's your positive 5 over 2. And we want to know where it's greater than 0. That means where it's above. Well, it's above when it's going this direction, isn't it? When the x's are going this direction, it'll be above. So obviously, let's take that one. It's going to be x less than or equal to minus 3. And it's going to be above when it goes out this direction past the 2.5. So when x is greater than or equal to 5 over 2. So there is your solution set. Okay? When it's less than or equal to minus 3, and when it's greater than or equal to 2.5. So that's where x is greater than not. Okay, so that's a nice standard one. It's an easy one. It does come off every so often. So again, just be aware of that. It does come up every so often. So let's have a look at the next bit of the question then. Aha, we've got a nice little simultaneous here. Okay, so we're going to solve this simultaneous. Again, it's nothing too radical as a simultaneous. It's a nice one. Okay, so I think the hardest bit of this is probably going to be dealing with the fractions. But listen, they're not the hardest thing to deal with. You know, I wouldn't consider them to be the hardest thing to deal with. One thing you can do with the fractions is you can just multiply by 2 on both these lines, because it'll give you the same thing. But listen, I'm going to take these two and solve it. So let's see what happens. So we have x plus y plus z equal to 16. And as I'm doing it, I'm just going to double this one. Okay, save me have the hassle later. So we have, if I double this one, I'm getting rid of that. So I'm going to get 5x plus 2y plus 20z equal to 80. So I need to cancel. So you pick the easiest one to cancel. So I don't know. Let me see. Double the top one, change the signs type of thing. Okay, so we're going to multiply the top by -2. Okay, so I'm going to write the top under the bottom. -2x, -2y, -2z equal to -32. Cancels. We're left with 3x plus 18y, or sorry, plus 18z equal to 48. So that's equation number 1. Okay, so now we're going to repeat the process with another 2. Again, it doesn't matter. Probably top and bottom, I would say, because I'm just looking there. I just have to double that and then change the sign and it'll work. So again, I'm going to do the same thing here. So I'm going to write down x plus y plus z equal to 16. Sorry, 16. And then I'm going to write down, I'm going to double this as I go along. So this is this line here, and I'm going to double it. Okay, so I'm going to get 4x plus y plus 16z equal to, sorry, I'm doubling it. 4x plus y plus 8z equal to 42. Now I'm just going to multiply everything here by -1. That's a minus, a minus, a minus. So that's 3x. Cancel the y's, plus 7z. And that's 16 from 42 is 26. So now I have equation number 2. So what do I do with equation number 1, number 2? I'll put them together and see what happens. Okay. So let me see. Put these together now and we'll see what happens. All right, so we have 3x plus 18z equal to 48, and we have 3x plus 7z equal to 26. So I'm just going to change these to minuses, cancel them. We get 11z is equal to, what's this, 22. Z must be 2. But if z is 2, we can substitute z back up in here. So if z is 2, we can put z in here. So that's 14 plus 3 times what is, so 4. X is 4. And if z is 2 and x is 4, I go right back up to the start. If x is 4 and z is 2, that's 6. So y is 10. And that is done. Okay? Just a nice question. I love those questions if they come up. They're brilliant. Okay. Right. So now have a look at this one. This is from question 15. It's a bit of an unusual one. Okay? Not your usual fare, as one would say. So we have to solve this equation and write any irrational solutions in the form of, you know, a nice little surdy cert. Okay? So these ones can be a little bit tricksy because all they're given to you to start with is very basic information. Now, statistically speaking, okay, so statistically speaking, this x cubed minus 3x squared minus 9x plus 11, okay? So that's your f of x. Now, we need to find one root, that's all we need. So we will try f of 0. Well, we know that's not going to work. You can see it by just inspection. 0, 0, 0, you still have 11, so it's not going to work. We'll try the f of 1. Then we'll try the f of minus 1. Then the f of 2. Then the f, you get the idea. But statistically speaking, if they've designed this question right, it'll either work for plus or minus 1, usually, and you won't have to go any further. Okay, so let's try it for 1. 1 minus 3 minus 9. 1 minus 3 is minus 2. Minus 9 is minus 11 plus 11. So it actually works for 1. So that means x equal to 1 is a root. Therefore, x minus 1 is a factor. So now we have a factor, and that's all we need to get this right. Okay? Because once we have a factor, we can just divide that factor into that cubic. Okay? So once we have a factor, we can divide it in. And of course, once we have it in, we can find the quadratic. And once from that quadratic, we can find the other two roots. So let's do this the super quick way, because we know this is a factor. Okay, so that means, and we know they want two other factors. So it's not a case that it doesn't have any other factors. So x into x cubed goes x squared. What's our trick for the last bit? It's going to be minus 11. So just multiply it back. Minus x squared. Change the signs. minus 2x squared, x into minus 2x squared is minus 2x, and there we have it. Don't go any further because that's what you need. There's no need to go any further. You've found the three pieces. Okay, remember the trick for the last bit. Whatever number is there, divided into that number, has to give you that number. The constant, it just has to. Okay, it's a nice little trick to know. Listen, I'll follow it through just to show you that I'm not. Bring down the remainders. Okay, x into minus, now reverse the process. Plus, minus, plus 11. X into minus 11 goes minus 11 times. You get the idea. So it does work, but you don't have to do all that if you've already gotten it right there. Stop right there because you've got it. Now, what do we do with this? Well, we know what to do with this. That is, they're both what you call this. They're both primes. There's absolutely no factors of 11 that are going to add or subtract be 2, so it's a minus b. So a is 1, b is minus 2, and c is minus 11. So we have minus b, so we have 2 plus or minus the square root of minus 2 squared minus 4 times a, which is 1, by c, which is minus 11, all over 2 times 1. Now give me a second on the calculator because I'm not going to do this out. This is a calculator job for everyone. Don't try and do this out. So on a calculator, that is 1 plus 2 root 3, 1 minus 2 root 3, and obviously 1. So there's my 3 solutions. There's my 3 roots. Okay, calculator gives me the plus version. If I just put it back in as the minus version, it's going to be the same thing. Okay, so that's brilliant. Okay, so I hope that helps you. Now, let's find another one then. Okay, so let's have a look at this one. Right, 2016, find the range of values of x for which the absolute value of x minus 4 is greater than or equal to 2. Now, listen, there's a couple of ways of doing this, of course, like anything else in life. You could, what I'm going to do is I'm just going to square both sides. That gets rid of this absolute value malarkey, then I can solve. Okay, so let's have a look at it. Squaring both sides. So that's going to be x minus 4 to be squared greater than or equal to 2 to be squared. Square the left, square the right, multiply them together and double it. Bring that over. That's going to be x squared minus 8x plus 12. 6 and 2, it looks like. And we need 2 negatives. So we have x equal to 2 and x equal to 6. Okay, so what we want to find out is where it's greater than 0. So again, do our sketch. It's a positive. It's a happy face. So 2 and 6. Now listen, this is not accurate, but this is just to test. This bit is just to test. So that's it. 2 is there and 6 is there. It's going to be greater than 6. So that direction, and less than 2. So when x is greater than 6, greater than or equal to 6, and where x is less than or equal to 2. There's your 2 possible solutions to this. Okay. Now, this one's a bit funner. I want a better word. Call that a better word. Probably don't want to call this a better word, but anyway, this is a simultaneous, but it's a bit of a nasty looking simultaneous. It's not one I'd, be bringing home. So we have x squared plus xy plus 2y squared equal to 4, and then we just have 2x plus 3y equal to minus 1. Now, nothing there looks nice at all. I've got x's and squares, and this is probably the second one is the one where I'll try and do something with it because it looks doable. It looks like you can do something with it. Okay, so let's manipulate the second one. So let's go, we have 2x equal to minus 1 minus 3y, x equal to minus 1 minus 3y over 2. So at least I have an x. Now I can substitute it back up in here. So I'm going to have minus 1 minus 3y over 2 squared plus minus 1 minus 3y over 2 times y plus 2y squared equal to 4. My God, now this is going to be fun. So, listen, the good news is that we can do this reasonably easily. I wouldn't say the most easy thing to do, but we can do it reasonably easy. So let's do this bit out. That's going to be over 4 when you square it. So square the left, square the right, multiply it together, and that's plus 6y, I think. Minus 1 times minus 3y is plus 3y, and double it, plus 6y. Plus, or well, this is going to be a minus. Minus, plus in a bracket. What have we got? Minus y minus 3y squared over 2 plus 2y squared equal to 4. So everything's going to have to be, well, I'm just trying to think here. 4 is, so everything's going to have to be multiplied by 4, basically, in order to get this back to where we're going. So let's try and multiply everything by 4. So they're going to have 1 plus 9y squared plus 6y minus 2y minus 6y squared plus 8y squared equal to 16. Oh God, okay, let's get this all together. So just see, we 9y, that's 3y squared, that's 11y squared. 11y squared. So I'm just going to knock out the y squareds just out of my head. Now we should have, let's see, 4 minus 2 is, sorry, 6 minus 2 is 4y plus 4y. And then bring that over. That's a negative 15 and a plus 1. It's, sorry, negative 16 and a plus 1 is negative 15 equal to 0. So that doesn't look nice at all as a quadratic, but I'm assuming this is going to work out somehow. So let's see what we got. Let's get me some more paper here because I don't like. Let me get some more paper here. So what have we got here? Bracket, 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 11y and y. I think a 1 and a 15. 1 and a 15. And oh God, let's get this right. It's going to have to be positive. So negative and a positive. So y is equal to 1 or y is equal to negative 15. Negative 15 over 11. Mother of God, that does not look nice. But anyway. Okay. So once we have our y's, we're going to have to sub them back in and get our x's. Okay. So if I take this one, this y equal to, and I pop it back in, then 2x plus 3, that means x is equal to negative 2. And if I pop this one back in, oh, mother of God. Okay, if I put that one back in, that's minus 30 over 11. That's plus 30 over 11 minus 1 divided by 3. Give me a second here. And it is, what do you believe? Don't believe this is 17 over 11. Okay, so bit horrible. My spidey sense will not like those ones. Those ones look solid. Those ones don't. But you know, it is what it is. And that's what you're getting when you're multiplying these things out. They're not exactly the nicest things in the world to multiply out. Okay, so that is a tough one. But that's the strategy, unfortunately, you have to go through with these ones. They're not nice to actually work your way through it. Definitely not nice. You know, I wouldn't be a big fan of them, for want of a better word. Okay, so on to our last little bit. So we have a nice little induction here. So prove by induction that 8 to the power of n minus 1 is divisible by 7 for all n an element of the natural numbers. Okay, so we've done a few of these. Okay, so prove it's true. n equal 1. So it's 8 to the power of 1 minus 1 divisible by 7. Therefore, divisible by 7. Okay, assume it's true. N equal to k, and k an element of the natural numbers. So we're going to say it's true for 8 to the power of k minus 1 is equal to some number. Is equal to a number. I don't know. Let's try and think of it. Some number times 7. You can call it 7n. Yeah. So 7 times a number. So it could be 7 times 1, 7 times 2. So it's, in other words, the number that's a factor. You can divide 7 out of it. Okay? Now, prove it's true. N equal to k plus 1. Okay? So n equal to k plus 1. N equal to k plus 1. Sorry, that's 1, isn't it? So what we want to do is we want to prove that this is going to be true. Okay? So let's have a look at it. I see and we've done this before, we can split this up. That's 8 to the power of a k multiplied by 8 to the power of 1 minus 1. And if I take the 8 over this side, that's 8 multiplied by 8 to the power of k minus. And of course, we know what. Let's see, I think minus 1. Now, looking back at this one, from this one, I can find the 8 to the power of k is there if I just add 1 to both sides. So this actually becomes 8 to the power, 8 multiplied by 7n minus 1. Minus. Sorry, that's a plus 1. Okay, we're getting there. So 7 8s are 56. That's true, isn't it? Yeah, 7 8s are 56. Plus 8 minus 1. And of course, you can see what's happening here. That's 56n plus 7. And I can factorize. You can get it. So this side is, as you can see, divisible by 7. Okay. So how do you wrap all this up? Well, n equal to 1 is true. And n equal to k is true. Therefore, n equal to k plus 1 is true. So because n equal to k plus 1 is true when n equal to k is true, by induction, it's true for all n, for all natural numbers. Okay, so that's that one done. So that is quite a nice one. So leave it at that. Bye. Okay, finish there, Jay.